Hey everyone, welcome back to the last section of our Formulating a Ration slide deck. This is all going to be focusing on mineral calculations, and I'll break this up into me teaching and then also us practicing. So in addition to the Pearson square method, nutritionists need to make other recommendations for animal feeds. So an accurate mineral calculations are very important, as we've discussed, because if we have too much of something or not enough of something, it could be very dangerous or harmful to the animal. It could also cause toxicity, especially in sheep, as we talked about in the previous lecture. Okay. So some key conversions that we have. So 1 ppm, and ppm stands for parts per million, is the equivalent of 1 milligram per kilogram. 1 kilogram equals 2.205 pounds. 1% equals 10,000 parts per million, and 1 pound equals 16 ounces. So whenever we do anything with this, whether it's on the end of the unit assessment or on a worksheet, I will always be sure to provide you those key conversions so you have them handy. A mineral mix contains 0.07 copper Cu. On a parts per million basis, how much copper does the mineral mix contain? So that's our first practice problem. So here's what we're going to do. We know that 1% equals 10,000 parts per million, right? Because that's given to us in our key conversions. 1% equals 10,000 parts per million. So we can set up an equation. We know that the mineral mix contains 0.07% copper. So we can take 0.07 divided by 1 and equal 0.07%. Okay? So if 0.07% is how much copper concentration is in this mineral mix, we can multiply it by 10,000 because we know that 1% contains 10,000 parts per million to give us a final answer of 700 parts per million. Okay, so that is kind of the most basic conversion that we have with these problems. Okay, now this is a little bit more challenging. So why don't you read this problem with me real quick? So if you are feeding a diet that contains 0.25 ppm parts per million selenium, how many milligrams per day of selenium are you feeding if the animal is eating 60 pounds of the diet per day? So if you feel comfortable and you want to try this out on your own, I would highly encourage it. You can hit pause and try your best and check back with the answer. Otherwise, feel free to just go along with the ride with me for a little bit. Okay, so our question again, we're trying to figure out how many milligrams per day that we're feeding if the animal is eating 60 pounds of the diet per day. So we know that 1 part per million equals 1 milligram per kilogram. So if we're feeding 0.25 parts per million selenium, we take 0.25 times 1, because 1 parts per million equals 1 milligram per kilogram, to equal 0.25 milligrams per kilogram. So now we've converted over. Okay, so we know that 1 kilogram equals 2.205 pounds, and the animal is eating 60 pounds per day. That's given to us in the problem. So we can take 60 pounds divided by 2.205 kilograms to get 27.21 kilograms. Okay, the reason we do that is we're trying to figure out how many kilograms the animal is eating per day. Okay, so now we have to figure out how much selenium is being eaten each day. So if we know that there are 0.25 milligrams per kilogram of selenium that are being fed to the animal, and that it is eating 27.21 kilograms each day, we need to determine the total milligrams. And we do this by taking 27.21 times 0.25 milligrams per kilograms. And that's going to give us 6.8 milligrams of selenium each day. Okay, so that was a little bit more of a complex problem, but hopefully you see how we did that. There were a lot of key conversions there. We will do lots of more practice on Google Classroom as well. So no worries if this is still kind of absorbing in your brain, and feel free to hit pause or go back and try to work through the problems on your own as well. Next problem. Try this one on your own. Okay, the calcium concentration of a diet is 6,600 parts per million. I want you to tell me what the calcium concentration of the diet is in milligrams per kilogram, and I would like you to tell me the calcium concentration of the diet expressed as a percent. So why don't you hit pause, try to work through this on your own, and if you get it right, awesome. If you get it wrong, hey, no worries, we're still learning together, and then we will do some more practice problems on Google Classroom. Okay, so hit pause, try your best. We'll reconvene here in a minute. Okay, so hopefully that gave you enough time to work through the problem. Let's see how you did. So, calcium concentration in milligrams per kilograms. We know that 1 parts per million equals 1 milligram per kilogram. That's given to us in our key conversions. We have 6,600 parts per million to equal 6,600 milligrams per kilogram because it's 1 to 1. 1 part per million equals 1 milligram per kilogram. That's a super easy conversion for us. Okay. Now, we need to figure out what is the calcium concentration of the diet in milligrams per kilograms. So we know that 1% equals 10,000 parts per million, and we know that there are 6,600 parts per million in our diet. So we take 6,600 divided by 10,000 to get a 0.66% calcium concentration. Okay? That is the problem. See that? That was pretty quick. We figured out the amount of milligrams per kilogram. That was a 1-to-1 conversion. And then we determined the percent concentration as a percent. Okay. Let's do another one. I think there's a few left in here. Okay. The copper concentration of hay is 5.6 parts per million, and cattle weigh approximately 1,000 pounds. Cattle are estimated to consume hay at the rate of 2% of their body weight. How many milligrams of copper are the cattle receiving from the hay? That's a big question. So kind of reread that to yourself if you need to. Again, the copper concentration of hay is 5.6 parts per million, and cattle weigh approximately 1,000 pounds. Cattle are estimated to consume hay at 2% of their body weight. How many milligrams of copper are the cattle receiving from the hay? If you think you can tackle this one on your own, go for it. Otherwise, we'll walk through it together because I have another extra step in here for you. So this is the extra step I was talking about. We first need to figure out how much hay the cattle consume each day. I don't give that to you this time. The problem tells us that they consume 2% of their body weight in hay per day. Hay per day. Pretty fun to say. So 2%, and they weigh 1,000 pounds. So that is going to give us 20 pounds of hay each day. See how I came up with that? 0.02%. Or 0.02 times 1,000 gives us 20 pounds. So we know that it eats 20 pounds of hay each day. Now our next step is going to be to convert 5.6 parts per million to milligrams per kilogram. So we know that 1 part per million equals 1 milligram per kilogram. So 5.6 parts per million, that's given in the problem, equals 5.6 milligrams per kilograms of copper. Okay. So now we're going to take this information and convert milligrams to milligrams per pound. We know that 1 kilogram equals 2.205 pounds because that's given to us in our key conversions, and our concentration is 5.6 milligrams per kilograms. So if we take 5.6 milligrams divided by 2.205 kilograms, this is going to give us 2.54 milligrams per pound. So finally, our last step here, we're almost there, I promise, is determining how many total milligrams of copper the cow eats each day. Okay, we've determined how many pounds of hay it eats. We've determined the concentration, which is 2.54 milligrams of copper per pound. Now we just simply need to multiply it. So we take our 2.54 milligrams per pound concentration that we just determined by the 20 pounds of hay that it eats each day. And that gives us 50.8 milligrams of copper. So if these problems are kind of intense, which they are, and they're still clicking for you, that's okay. We have lots of practice problems on Classroom. But I would encourage you to hit pause, rewind, go back if you need to, and let me know if you have any questions. So again, our learning targets for the day. Now you'll be able to explain the importance of formulating a balanced ration. You can demonstrate formulation of a ration utilizing the Pearson square method. You can evaluate a feed bag based on its nutritional and marketing properties, and you can calculate recommendations for minerals in a ration. Again, if you have any questions, always feel free to send me an email, reach out. We can Google Meets. We can talk about this. We can work through some practice problems together. Have a great rest of your day.